In the vast expanse of our universe, there exist celestial wonders that have captivated astronomers for centuries. These wonders are not just distant points of light but are rich with stories and secrets waiting to be uncovered. Among these cosmic marvels are globular clusters, densely packed spheres of stars that resemble celestial jewels scattered across the cosmos. These clusters are some of the oldest known objects in the universe, dating back to the early stages of galaxy formation. These stellar swarms are not just beautiful sights to behold but also hold invaluable clues about the history and evolution of our universe. By studying them, astronomers can gain insights into the processes that shaped galaxies billions of years ago. Imagine a sphere teeming with hundreds of thousands, even millions of stars, all bound together by gravity's relentless grip. Each star within these clusters has its own unique journey, contributing to the collective story of the cluster. These are the globular clusters, ancient stellar cities that have witnessed eons of cosmic history. They serve as time capsules, preserving the conditions of the early universe. Their sheer density and age make them unique laboratories for studying the lives and deaths of stars and the dynamics of gravity. Researchers can observe how stars interact within these dense environments, providing a window into stellar evolution. These celestial treasure troves are not scattered randomly throughout the universe. Instead, they follow specific patterns and distributions that tell us more about the structure of galaxies. They reside in the halos of galaxies, forming a spherical distribution around these massive stellar islands. This positioning provides clues about the gravitational forces at play and the history of galaxy formation. Our own Milky Way galaxy is home to over 150 known globular clusters, each with its own captivating story to tell. These clusters are not just objects of beauty, but are also key to understanding the larger cosmic puzzle. Globular clusters are more than just random collections of stars. They are fascinating cosmic structures that have intrigued astronomers for centuries. They are highly organized structures held together by their own immense gravity, forming a spherical shape that can contain hundreds of thousands or even millions of stars. The stars within a globular cluster are not uniformly distributed. Instead, they are concentrated towards the cluster's center, creating a breathtaking spectacle of stellar density. This central concentration is a result of the gravitational pull that draws stars inward. As we venture closer to the core of a globular cluster, the density of stars increases dramatically. The core can be so densely packed that it appears almost like a solid mass of light. The distances between stars become so small that stellar interactions and even collisions become more likely. These close encounters can lead to fascinating phenomena such as the formation of binary star systems or even the merging of stars. These interactions can have profound effects on the evolution of stars within these clusters. They can alter the star's orbits, trigger new star formation, or even result in the ejection of stars from the cluster. The stars that inhabit globular clusters are not like the stars we find in the galactic disk, such as our own sun. They are typically older and have different physical characteristics. They are much older, some of the oldest stars in the universe, and their chemical composition differs significantly from younger stars. These ancient stars often lack the heavier elements found in younger stars, indicating they formed in a much earlier epoch of the universe. This difference in composition provides valuable insights into the early universe's conditions shortly after the Big Bang. By studying these ancient stars, astronomers can piece together the history of our cosmos and understand the processes that shaped the universe as we know it today. Globular clusters are not found within the swirling disks of galaxies where star formation is actively taking place. Instead, these ancient stellar cities reside in the halos of galaxies, vast spherical regions that extend far beyond the visible limits of the galactic disk. The Milky Way's halo, for example, is a sparsely populated region of space where globular clusters, along with individual stars and dark matter, reside. These clusters orbit the galactic center, their paths taking them far above and below the galactic plane, providing a unique perspective on our galaxy's structure. While globular clusters are most commonly found in the halos of galaxies, they are not exclusive to these regions. Some dwarf galaxies, much smaller than our Milky Way, also host globular clusters, suggesting that these stellar swarms can form in a variety of environments. The formation of globular clusters is a topic of ongoing research, but astronomers have pieced together a compelling narrative based on observations and simulations. These stellar cities are believed to have formed early in the universe, during a time of intense star formation. One prevailing theory suggests that globular clusters formed from massive clouds of gas and dust that collapsed under their own gravity. These clouds were likely much denser than the clouds that give birth to stars today, allowing for the formation of a vast number of stars in a relatively small volume. Another possibility is that globular clusters formed through the merging of smaller stellar groups. As these groups interacted gravitationally, they could have coalesced over time, eventually forming the massive, densely packed structures we observe today. Section 5. Ancient Stellar Dwellers. A glimpse into the past. The stars within globular clusters are not just numerous, they are also incredibly old. These clusters are like cosmic time capsules, preserving the conditions of the early universe. In fact, they are some of the oldest stars in the universe, dating back to the early epochs after the Big Bang. These ancient stars have witnessed the birth and evolution of galaxies over billions of years. This ancient lineage makes them invaluable tools for studying the early universe and stellar evolution. By examining these stars, astronomers can piece together the history of our cosmos. Unlike stars in the galactic disk, which are constantly enriched with heavy elements from supernova explosions, the stars in globular clusters formed from a primordial soup of hydrogen and helium, with only trace amounts of heavier elements. This makes them unique laboratories for understanding the early chemical processes of the universe. By studying the chemical composition of these stars, astronomers can gain insights into the conditions that prevailed in the early universe. This information helps us understand the processes that led to the formation of galaxies and other cosmic structures. The ancient stars within globular clusters provide a glimpse into the past, allowing astronomers to study stellar evolution over cosmic timescales. These stars act as a bridge to our cosmic origins. By observing these stars at different stages of their lives, astronomers can refine their models of how stars form, evolve, and eventually die. This ongoing research continues to shed light on the life cycles of stars and the dynamic processes that shape our universe. Section 6. Cosmic Clocks and Galactic Evolution. The age of globular clusters is not only of interest for understanding stellar evolution but also for constraining the age of the universe itself. Because these clusters formed early in cosmic history, their age provides a lower limit on the age of the universe. Astronomers use various techniques to determine the age of globular clusters, including studying the evolution of their stars and measuring the decay rates of radioactive elements within them. These measurements have consistently shown that globular clusters are incredibly old, with ages ranging from 10 to 13 billion years. The distribution and properties of globular clusters also provide valuable clues about the formation and evolution of galaxies. Their presence in galactic halos suggests that these regions formed early in the universe, likely through the accretion of smaller galaxies or the collapse of massive gas clouds. Section 7. Dark Secrets of Globular Clusters. While globular clusters have revealed much about the universe, they also harbor mysteries that continue to puzzle astronomers. One such mystery is the presence of black holes within these stellar swarms. Black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape, are thought to be the remnants of massive stars that have collapsed under their own gravity. While black holes are challenging to detect directly, their presence can be inferred from their gravitational influence on surrounding stars. Astronomers have found evidence for black holes in several globular clusters, suggesting that these dense stellar environments may be ideal breeding grounds for these enigmatic objects. The study of black holes in globular clusters offers a unique opportunity to understand the formation and evolution of these extreme objects. Section 8. Unanswered Questions and Future Explorations. Despite decades of research, globular clusters continue to pose intriguing questions for astronomers. The exact mechanisms of their formation, the role of black holes in their evolution, and the nature of the dark matter that may lurk within them are just a few of the mysteries that remain to be fully unraveled. Future observations with advanced telescopes, both on Earth and in space, will undoubtedly provide new insights into these celestial treasure troves, By studying their stars, their dynamics, and their interactions with the surrounding galactic environment, astronomers hope to gain a deeper understanding of these ancient stellar cities and their place in the grand cosmic tapestry. Section 9. Conclusion. Enduring Enigmas of the Cosmos. Globular clusters, these ancient stellar cities scattered throughout the universe, stand as enduring testaments to the vastness of space and time. They are cosmic time capsules, preserving within their dense stellar populations clues about the early universe and the processes that govern the lives and deaths of stars. As we continue to explore these celestial wonders, we are constantly reminded of the interconnectedness of the cosmos and the intricate dance of gravity, matter, and time that has shaped the universe we observe today. Globular clusters with their ancient stars, their mysterious black holes, and their enduring enigmas beckon us to continue our exploration of the cosmos, seeking answers to the fundamental questions about our place in the universe.